So let's say you've spent, a lifetime of development, early on in development, you wired up, the appropriate networking from the eyes, right? From those rods and cones through the bipolar cells, through the ganglion cells, through the thalamus, into the cortex, into primary visual cortex, into the temporal lobes for identifying what objects are, into the parietal lobes for identifying where those objects are in relationship to your body, in position in space. And remember, we've been learning a lot about how there's lots of feedback, projections to all of these anticipatory or biased expectations, right? That we have developed with, visual experience, that can let us see, like a multicolored brain model, for example, or a giant styrofoam brain, or a skull, or a cup of coffee, all sorts of things like that, right? Well, your perceptual experiences are based upon, the incoming, sort of what they call bottom-up information, bottom-up input from sensory detection, right? Both external, stimuli, and also internal stimuli, the stimuli of the body. And the sort of anticipatory kind of biased expectations, right? That sort of route things in specific ways. And should these, sensory detectors, start to degrade, as they inevitably will, people develop what's called macular degeneration, right? Where they start to lose, cellular architecture in the retina, and they start to go blind, right? Or, it turns out that we have like 5 times as many touch receptors when you're a baby, than you do when you're, middle-aged. So yet, your perceptual experiences are quite remarkable and, extraordinary, and really based a lot on what's happening in networks in here, in the brain. There's a relationship between the sensory input, the bottom up, and the, top down sort of processing. But as there's degradation of the inputs, there can actually be rather, strong and lasting preservation of your perceptual experiences, because that's dependent on the brain. There's some really fascinating sort of conditions that can result as people, for example, develop macular degeneration, start to go blind, etc. So one syndrome that's just extraordinary, and there's a wonderful writer who's a neurologist who passed, recently, named Oliver Sacks, who has a TED Talk that I'd like you to take a look at on this syndrome. It's called Charles Bonnet syndrome. And, Charles Bonnet, his grandfather, who was like in his 80s, I believe, this was, in the 1700s, he wrote about his grandfather because his grandfather, was having severe sort of macular degeneration, and yet he described an extraordinary world of visual experience, of perceptual experience in the visual realm. He saw, things floating in front of him. He could see, little miniature images of stuff that he'd seen, or that that were on his walk, on his desk. He saw lots of things that weren't there. He had these really remarkable hallucinatory kinds of experiences. And actually that's fascinating, because it turns out that many people who develop, loss of visual input will actually experience these powerful Charles Bonnet hallucinations, and yet often won't report them because they're afraid often. They could be older, and they could be in maybe a nursing home setting or something like that, and they're afraid that they're going crazy. They're going to be perceived as developing dementia or something, or they're going to be prescribed all these drugs that are going to worsen their circumstances. And really, one of the most powerful kinds of ways of approaching Charles Bonnet is to be open about it, and actually to just acknowledge it. I mean, to say like, yeah, this is your brain. It's now been freed up, from the bottom up input. And it's kind of active as a result in fascinating and interesting sorts of ways. So when you put somebody who's experiencing Charles Bonnet hallucinations in an fMRI scanner, for example, an imaging scanner, and look at areas of the brain that are active when they report these hallucinations, you will see significant activation in those temporal lobe regions that are involved in identifying visual objects. So they're describing all these things that they see. There's lily pads on the floor, there's a cow in the corner or something like that. Well, you'll see areas of their of the what pathway in the temporal lobes, the object recognition regions, very active in the brain. So Charles Bonnet syndrome is just fascinating, and these kinds of sort of hallucinatory syndromes are common in other sensory systems as well. There are auditory hallucinations that people can experience. There's something called musical ear syndrome, where people will, it's very analogous to Charles Bonnet, they will hear, suddenly, unbidden, with no volume control and no choice of playlist, like very loud music of some sort, when they've had significant damage to the inner ear, when they've started to lose the sensory inputs basically from the inner ear. Many of us have similar kinds of experiences. If you've lost higher frequency hearing, you often can hear a very high pitched ringing. It's called tinnitus, right? That's, there's no sound there, actually. There's no sound waves. You don't have the architecture to detect, that anymore, because they've been blown out by, all the concerts we've gone to and things like that. However, the architecture in the brain, in the cortex, in, primary auditory cortex in the temporal lobe still exists to allow for the perception of that high-pitched sound, and it'll be active. So these areas that are deprived of this bottom-up stimulation often become sort of implacably active. They come up at various times. It could happen when people are more stressed, for example. But these syndromes are really interesting windows into how the brain is functioning. Another one I just want to mention really briefly is something called the exploding head syndrome, which sounds terrible, but it turns out it's actually quite common, where people, maybe it often sometimes happens when they're falling asleep or just waking up, but there's like this sudden sense of an heard explosion, basically, but it feels like it's actually inside your own head. And actually, in many undergraduate classrooms, when we ask people about this, there's usually one or two people who've actually experienced exploding head syndrome. And when we go for outreach in public schools, we often hear that, quite a bit as well. So, I mean, it sounds terrible, and I apologize if it's happening to any of you. But all of these syndromes are really remarkable, testament to the brain's effort to understand and, to some extent, hallucinate, aspects of our perceptual experience by trying to link, this sensory detection, this incoming, information, right, with the structures that have formed from developmental experience that, allow us to sort of anticipate or predict or jump to conclusions sort of probabilistically what this is likely, under various circumstances to be. And, and when those decisions are made here, you see it or you hear it. That's where perception actually is.